All students are excited by space, but it's not always easy to bring the wonders of the cosmos to life in the classroom. The Holyfield School's solution was to organise a visit from planetary scientist and STEM career role model Sheila Kanani. She's here to spice up their science lesson by cooking up a comet in the classroom.
I'm Sheila Kanani. I'm a PhD student in planetary science at the University College London, but particularly at the Mullard Space Science Laboratory, which is the Space and Climate Department of UCL. I'm working on using data from the Cassini spacecraft. Mullard Space Science Laboratory built one of the instruments that's on the spacecraft at the moment, and the spacecraft's orbiting Saturn. The building that I work in is a big old mansion. It's a fantastic place to work because it's in the countryside. It's really beautiful. It's good because we've got the offices and the data analysers, but we also have the people who build the components of the satellites, even the people who design them, so you can really see a satellite from conception to birth to launch, and then work out the data afterwards as well. So it's a great place to work. I'm still looking for the button that will open up the secret basement with the Batmobile inside.
Like Sheila, there are many practising scientists and engineers across the country, keen to raise enthusiasm for science, technology, engineering and maths, and happy to offer their specialist knowledge and expertise to schools. Today, Sheila has been invited by science teacher Joe Gale to work with his Year 8s at the Holyfield School in Surbiton. This isn't the first time he's invited Sheila into the school.
Last time Sheila visited, she gave the background of her research, so she informed pupils of what kind of research is going on in research labs around the country, looking at the planets within our solar system. Today we want to extend it, so we want to do a bit more of a workshop and show how we can model some of the things that are out there in our solar system in a science classroom.
But before Sheila gets a chance to show off her culinary skills, she whets the students' appetite with an introduction to comets and where they come from.
Before the sun was formed, before the planets were formed, it all started off with a cloud of gas and dust about 4.5 billion years ago. And due to gravity, the gas and dust started rotating and whirling round. The core of the disk, the middle of the disk, heated up. But the outer edges of the solar system remained really, really cold and icy. See, the water froze, and it froze into dust and clumps, you know, like little snowballs. And then the clumps all collided together and made bigger clumps and bigger clumps. And these big clumps of ice and dust and water are what we know today as comets.
It's only recently that we've discovered a comet's ingredients, and Sheila explains to the students exactly where she got the recipe from.
Now, there has been a mission to a comet where it sampled exactly what the nucleus was made of. It was a mission called the Deep Impact mission. The spacecraft went really, really close to the comet, but then it actually let off a smaller piece of the spacecraft, which impacted with the nucleus of the comet. And as it impacted, if you imagine sort of bashing into the ground, all these bits of the nucleus came flying off. And as the bits of the nucleus came flying off, Deep Impact could measure exactly what the nucleus was made of.
The quest to understand the makeup of our solar system never stops, and Sheila is currently occupied on a mission to find out more.
A normal day at work is me on my computer looking at data coming directly from Cassini. Now, Cassini's orbiting Saturn at the moment, and it's been up there about 4 years. And MSSL, we built one of the instruments that's on board Cassini, so we get the data from that instrument. This is an example plot here of the electron data, and the different colours represent different densities of electrons. There's this huge streak of green down the middle, and that actually occurs when Cassini, the spacecraft, crosses the orbit of one of the moons, Enceladus, and Enceladus actually absorbs all the electrons. The other interesting feature in this data here is these red spikes, and this is particularly what I'm looking at the moment. I'm trying to find out why these spikes are occurring, and we think that they're occurring because of Enceladus. We know for a fact that Enceladus is spewing off water ice constantly like a huge volcano, and maybe we think these spikes are related to this geyser of water that's coming off of the moon as well. It could be anything really. We haven't looked into all the possibilities yet, so it's still very exciting. It's a bit like being a detective trying to find out why things are happening, and finding a solution at the end of it is such a satisfying feeling.
Back in the classroom, and it's time for Sheila to start cooking up her comet.
Now I need my first volunteer. The first ingredient is water, and water's the same be you on Earth or in space. So you have to wear the chef's hat. And if you just grab the bottle of water and put some water into the bowl, keep pouring for a little bit. That should be enough. We can always add some more afterwards if we need to. Thank you very much. Silicates can be found on Earth in sand and dirt. And just get a handful of sand, and then there is...
Too small.
You could pretend. Just grab a handful of sand or a spoonful of sand and mix it into the water. Ammonia is found in nail varnish remover and also window cleaner. So just a few sprays of window cleaner and then give it a little bit of a mix as well. Thank you very much. So it's quite difficult to get planetary science into the classroom without just showing a movie or something, which I could do, but it's not as hands-on. So it's quite a nice hands-on activity, being able to see what things could look like if you could go to them. Does anybody know what on earth we can find methane in? Yep.
Farts.
Yeah. Charming. Carbon compounds can be found in charcoal. That's great. Just a nice glug of vodka in there. Organic compounds or material can be found in Worcester sauce. So we just need a few drops of Worcester sauce in the bowl and then give it a good mix. The ice in a comet is made from dry ice. Now, dry ice is also known as carbon dioxide ice, so the air that we breathe out in ice form. The problem with carbon dioxide ice is that it's very, very cold. It's minus 80 degrees C. So if you touch it or if you get it in your eyes, you get a really nasty ice burn. So I'll just smash it up with a rolling pin. You see the whole bag starting to freeze. It's a bit like making apple crumble. And then we're going to pour, oops, if I can grab the end of it. Pour the ice in. See all the carbon dioxide gas coming off. It looks like I'm making a witch's brew.
When we have these kind of visits, there are so many benefits. It can really enthuse the pupils with science again. Obviously, a lot of them view scientists as images they see in textbooks. They're often black and white and they don't have any connection to them. So it's really exciting to get a real research scientist coming in and they can see them in the flesh and realise that they are young people with a lot of energy and enthusiasm for science, and that can really inspire them and recapture their interest in science.
And that is how you make a comet in the classroom. In my own time, I do like a bit of amateur astronomy. The first time I saw Saturn in a telescope, when you look at it without a telescope, it just looks like a speck of light or another star. And then you look at it through the telescope and you can see the rings. And just thinking this is how it all began with scientists like Galileo. If you've got the enthusiasm and you like learning and you like exploring things that haven't been explored before, then physics and doing space science is definitely a thing for you. It can't be exciting every single day. But when you do get that breakthrough, even if it's months later, it's so fascinating to see all the pieces of the puzzle fit together. And especially with the space industry, it's a very long process. I mean, spacecraft, from the idea of them to when they actually launch, it can take sort of 20 years. And even to get to their destination, it can take tens of years. So it's a very long process. But when you see your instruments strapped to the back of a rocket launching from Kennedy Space Center, it definitely makes it all worthwhile.
Sheila rounds up the activity by explaining exactly why it's important to understand what comets are made from and the secrets they may one day reveal.
Comets started with the same materials that the Earth started with 4.3 billion years ago. So if we look at what comets are made from, because they haven't changed over time, we can look at a comet and see exactly what Earth would have been like 4.3 billion years ago. And comets may eventually help us find the sort of makeup of life, DNA, and tell us how organic matter, how humans were created.
With today's activity, I really would like to follow it up. I'd like them to be able to sort of carry out some research as planetary scientists for themselves, and there are resources out there where they can actually do that, and the National Schools Observatory is really good, and that would be a great link on from this.
For pudding, Sheila opens the floor to questions, allowing the interested students to inquire how they might follow in her footsteps.
How did you become a space scientist?
The path to becoming a space scientist is varied depending on what you're interested at school. You could do maths, you could do sciences, you could do engineering, so there's loads of possibilities. Mathematicians are always needed because maths is the language of physics. Physicists are obviously directly related to space science, but if you were, for example, an engineer, you could then build spacecraft.
What could we do now to get into space science?
Things like work experience or shadowing a space scientist for a day, go to a lab and just see what they get up to. You could also go on summer camps. There's loads of space science and astronomy summer camps in the UK and also in America.
One of the big benefits of these activities is that they can actually see where science will take them in the future, and if they are interested in science, it gives them a goal because they can see these careers for themselves. They can see where they could go if they followed science through to university.
So has Sheila's enthusiasm for space science left the students hungry for more?
Yeah, I really enjoyed it. It was really good and different because we'd never seen comet, how it's made and that kind of thing. It's not what we normally do in lessons. We normally do smaller experiments and that kind of thing, so it was really good.
The best bit of the lesson for me was when she took out the finished comet, because it was really interesting to see the actual, what a comet would look like.
Yeah, I think I would like to quite work in space science when I'm older, because it looks quite fun.
I hope I did create a few potential future scientists, engineers, mathematicians. We had 16 pupils in the class today, but even if we just captured the imagination and the enthusiasm of one of them, then that would be fantastic.
One day may not change someone's view on science completely. I can accept that, and these activities are designed to sort of open their eyes to the possibilities in science, and that can lead on to them to really developing a love for science, and that can help to push pupils towards a future career in science, which is really important, and that's what we aim to do with these days, and that's what we aim to do with science teaching, full stop.